Hey guys, so today we're still going to be looking at some quadratics. This quadratic mother function isn't going anywhere. So we've graphed it, we've changed its form, but we haven't done is solved it. And that's what we're going to talk about this unit. So what is the solution to an equation? So solution, root, zero, answer, solve this, they're all the same thing. If you look at it graphically, it's where your graph, in this case a quadratic, a parabola, crosses your x-axis. Your x-intercepts are your solutions. And that's for any kind of equation. If it's talking about a solution root zero, it's meaning where does that graph cross your x-axis? And if you think about that, the y value whenever it crosses the x-axis is 0. So that's how we solve an equation. So we have a few different scenarios here for a quadratic specifically. So if we're talking about our parabolas, it could have two solutions. It could do something like this, or of course it could do something like this, either way. But it crosses the x-axis twice, you see? 1, 2. 1, 2. That's two solutions. It doesn't matter if it's pointing up or down. One solution would be something more like, here's my vertex right on the x-axis. And, either up or down, doesn't matter. But it's only got one solution because my vertex, my minimum or maximum, is on the x-axis. And then you might have something like this. It ain't crossing the x-axis. Or something like this. It ain't crossing the x-axis either. If it doesn't cross the x-axis, there's no x-intercept, which means there's no solution. And notice it says real solution. We're actually finally going to start talking about eyes very soon. Told you at the beginning of the year, we talked about that much later. Now it's later. Yeah, this week before Christmas. That's our latest. Skips next week, who knows. So it's the x-intercept. So why don't we graph it and find out where the x-intercepts are? Sounds reasonable, right? So this is not new. We've done a freak ton of these. So I'm just going to do it. You, of course, could use a calculator and get your vertex there. I'm going to just do it. It's in standard form, negative b over 2a. Oh, I'm going to use my calculator because I don't feel like doing fractions in my head. Mode 5, 3, 2, 6, and 0. Negative 3, 0. So negative 3 halves, negative 9 halves. Okay, so negative 3 halves, negative 9 halves would be my vertex. Okay. Now, of course, this is going to be negative. That's 6 over 4 is 3 halves. But I didn't feel like plugging that in my head. That's why I used the calculator. Calculators are good for that. That's negative 1.5, negative 4.5. There-ish. And then we go up a times my odds. So 1, 3, 5 times 2. That's 2, 6, and 10. Obviously not going to go up 10 because, well, yeah, it's not going to reach. But let's try it. Right 1 up 2. This is nasty. Left 1 up 2. Okay, let's do 6. Right 1 up 6. 1, 2, 5, 6. So like there. Something like that. Right 1 up 6. Left 1 up 6. 1, 2, 3, 4, 5, 6. Yeah, 10's not going to make it. Okay, so I'm gonna graph this. I'm gonna use a different color so I can see where points are. Okay, and if I graph that, it crosses the x-axis like blue. Hey, here-ish and here-ish. Yeah, so that's why I don't like graphing to solve things, because yeah, not exactly sure where that is. It looks like it could be 0 and -3, maybe. So x equals 0, x equals -3. Seems about right, but I don't like about right. I like having an answer. That's why I don't like graphing to solve things. But we've been graphing, so sometimes it'll be nice. This it's not nice on this one. Let's try now. Negative b over 2a. Enough negatives for you? That's going to be -5. That's going to be 25, 50. Oh, 0. No, let me double check. -1, -10, -25. I think that's going to give me 0 on my, yeah, there it is. -5 and 0. -1, 2, 3, 4, 5, 0. Oh, hey, that's an x-intercept, isn't it? That's a solution. We continue graphing. Maybe we'll have another one. Let's see. A is -1, so that's -1, -3, -5. Right one, up a -1. Mirror that. Right one, -3. Right one. Yep, obviously that is not going to cross the x-axis again. Remember, it has one solution if your vertex is on your x-axis. So graph the dang thing. And my answer, my solution, my 0, my root, my x-intercept is -5. That's the answer to this. Solve this equation, your answer will be -5. Okay, let's look at this guy. -8 over 2 times -1. That's going to be a +4. That's 32, -16, that's 16, -1. Check myself because it's like 10 o'clock and I haven't had coffee in a while. -1, 8, -17, 4, and -1. Cool. I didn't screw up. 4, -1, boom, there's my vertex. Now it's, again, A is -1, so -1, -3, -5. Bottom, right one down 1, mirror, right one down 3, mirror. This is not new at all. Right one down 5, and mirror. Graph it. It's got a kind of point, but rounded that butt off a little bit. That's okay. Yeah, it's not touching the x-axis, is it? So what's my solution? There isn't one. No solution. Did I spell that right? Cool. It doesn't cross the x-axis. It doesn't have an x-intercept. It has no solution. So our answer is no solution. So that was a review kind of thing, graphing, and it's possible to solve it like you see, but then sometimes it's just guessing kind of. So I don't like graphing to solve these. It's going to be very minimal that we have of graphing to solve these. I'm going to get an algebraic method that works every single time. Let me teach you something else first. Oops. Factoring. We're going to solve these quadratics by factoring soon. But first, let's make sure you remember what factoring is. We did some factoring whenever we were completing the square to make a perfect square trinomial whenever we were doing a standard form to vertex form. You know, when we added the little b over 2 squared thing, and then it magically turned into that other thing, a little square on it. That's factoring. But the very first thing, you know, step 1 was parentheses, and the step 2 was factor out a. Well, a was what we call the GCF, the greatest common factor. Actually, it wasn't, but it's the same process. So we're going to factor out the GCF. We're going to do the same thing, but this time we have to figure out what the GCF is. We did it in 6th grade, do you remember? Anyway, so you got to look at this thing and look at that thing, and what is the biggest thing, not necessarily a number, that these guys have in common? Let's see. This guy's got a 12 and an 18. So numbers, I got a 2. Yeah, they both have 2 in them. They both have a 3 in them. That's 6. They both have 6 in them. Yeah, they both have 6 in them. That's our GCF. Because this guy's got a K, but that guy doesn't have a K. So I'm going to factor out a 6. And if I factor out a 6, if I undistribute, I'm dividing. So that's, let's see, 12K divided by 6. That's a toughie. 2K. Minus, I didn't change the sign here, so why would I change the sign? 3. Oh, done. And of course, you can always check yourself, distribute it back out. 12K minus 18, we're good. Oh my goodness gracious, this has all kind of things in it. But remember, you just take out what biggest things they have in common. You look at your numbers, you look at your X's, Y's, Z's, alphas, betas, dogs, fish, whatever. Whatever you got, look at each individual different kind of thing separately. So first I'm going to look at these 40s and these 64s. And if you don't know how to find the GCF, if you can't think, well, I've got a 2, then I got a 4, you can keep going that way, sure. Or, yeah, this guy, mode 1. There's a GCD button on here, which is the same as GCF. So GCD of 40, comma, where's the comma? I forgot. There it is. Shift, close parentheses, 64. Gives you 8. So the biggest number that 40 and 64 have as a factor in common, the greatest common factor, is 8. So that's going to be that piece. Then they both have X's and they both have Y's, so I'm going to have some sort of X's and some sort of Y's. I'm still factoring out the GCF here. I'm still figuring out what it is. What do they all have? This guy's got 8 X's, that guy's got 4 of them, so they both have 4 of them. This guy's got 1 Y, that guy's got 1 Y, so they both got 1 Y. Again, factoring out, we're dividing. 40 divided by 8, 5. X to the 8th power divided by x to the 4th power. Remember, whenever you're dividing powers, you subtract. That's x to the 4th power. Y divided by y. Well, y to the 1st power divided by y to the 1st power. 1 minus 1 is 0, and 0 power is 1. Or, of course, you know, anything divided by itself is 1, so y divided by y is 1. That's 0. 0 divided by 0, that's a whole other story. Anyway, plus 64 divided by 8 is 8. And x to the fourth. We took an x to the fourth out. We're left with 1. So it's just, we're multiplying by 1. We're just not changing anything. So I'm not even going to write times 1. I got 1 and I got 1, so I got done. Check yourself by distributing it. 8 times 8 is 64, x fourth y. 64, x fourth y. Good. Moving on. And I'm going to do these real quick, like 14, 35, and 7. Well, they all have a 7 in them. 2, 3, and 6 m's. Well, they all got 2 m's in them. That's going to be 2 m. That's 3, right? When we divide, we subtract, remember. So 6 minus 2 is 4. That's a weird looking thing. There, 5. 3 minus 2 is 1. Minus, well, I can't just put nothing here. It all cancels. 7m squared divided by 7m squared cancels to a what, though? To a 0? Because we're dividing something by itself. Anything divided by itself is 1. So you got to put the 1 because there's nothing else to do. Over here, we had an 8 already, so we didn't need to do times 1 times 1. But over here, we didn't have anything, so we better put the 1. Distribute, check yourself. 7m squared times 1 is indeed 7m squared. Negative, whatever. Okay, so 3 and 5 and 8, they all have a nothing in, no. A, there's 1 there, there's 2 there, there's 1 there, so I got 1. Got 2 B's, 1 B. Well, okay, I got 1 B. So it didn't mess with the 3. A divided by A is 1, but again, I got something already, so I don't need to write the 1. B squared divided by B is B. Didn't mess with the numbers, so that's still a 5. A plus 8. Didn't mess with the numbers, and AB divided by AB is 1. Okay, that's GCF. Breathe. When factoring, always look for a GCF first. Okay, I said that very monotone-like. When you're factoring, always look for a GCF first. Maybe it worked now. GCF first, every single time. Look for it. That is like super important. If you don't do that and it has a GCF, you're just going to not factor correctly. It'll just mess you up all together. It's not going to work. GCF first. So now, different methods of factoring quadratic. I'm sure you've seen several different methods. Or none. I don't know. Should have seen several different methods. What you're probably most familiar with is the area model. The box method, as some teachers call it. It's really just the area model that you learned back in my wife's class. You know, whenever you're doing expanded form and multiplying all that mess. To be honest with you, this will be the second time I've ever used the area model. The first time is whenever I figure out how to do it to show you. But yeah, I don't do it this way, but I'm gonna show you in case you're familiar with it, you already know how to do it. Do it, I don't care. One extremely important note, not all quadratics are factorable. So this will work every time your quadratic is factorable. Graphing will only work if you don't suck at drawing. So this is better. We'll get to the best way later. But this is better. At least you won't have to guess at what your answer is from what you got. You'll be able to actually see, okay, this is what I got, or, oh, I can't do it. So the main idea here for the area model. So let me go back. This is ax squared plus bx plus c. That's the standard form of a quadratic. That's what we got here, okay? This is always A, this is always B, this is always C. No matter what we're talking about with a quadratic, that's A, B, and C. Okay? Okay. So what we do is we put our first term, that's in standard form, so it's descending order, so it's the term with x squared on it, in the first box. Then we put our last term in our last box. And then we got to figure out what goes in these two boxes. Okay. So we got to make it add up. Well, actually, combine. We got to make it combine to get us this. Combine. Combines to give us B. What are you looking at though? I mean, 1 minus -4 is 5, but I can pick all kind of things and combine and get 5, right? So what's special? What do I have to do? AC. We got to look at A times C. C is 12 times -2 is -24. Okay, so I'm got to think here. I have factors of 24. Okay, now it's a negative, so one's positive, one's negative. So we're going to subtract. So 1 and 24, no. 2 and 12, no. 3 and 8. Oh, hey, there we go. 3 and 8. Now, those have to have x's on them because this is not just a 5, it's a 5x. Which is like, wait, that's 8x plus 3x is 11x. You're absolutely right. It needs to be -24, so one of these has to be negative. Which one do you think? Well, if I want a positive 5, I need the bigger number to be positive, so I need the little number to be negative. Ta-da. And now this is in my way a little bit. So now we've got to factor out the GCF 4 times. We got to factor out the GCF here, the GCF here. We got to factor out the GCF here. We got to factor out the GCF here. And that will give us our factors. I'm going to do it in red. So I'm going to look at this yellow one going up and down here. 12x squared and -3x. Well, they both have a 3 in them and an x. Because, you know, that's what it is. It's 12 and 3. They both have 3. They're x squared and x. They both have an x. All right, what do these two have in common? That's got an 8 and that's got a 2, so they both got a 2. Okay. Now we're here. That's a 12 and an 8. Ooh, that's 4. X squared and x is x. 4x. Okay, okay. Now here's a tricky one. -3x and -2. Those don't have 3 and 2 don't have anything in common. They both have a negative. You got to take the negative. So you can't just write a negative, can you? No, you can't. So if they don't have any factors in common, if your GCF isn't anything, it's 1. Everybody's got a factor of 1. 3's got a factor of 1. 1 times 3. Anything times itself times 1 is product. There you go. 1's always a factor. Donkey. 1 times donkey is donkey. So even if you're messing with a donkey, it's still going to have a factor of 1. So there it is. So let's write these as factors. 4x minus 1, 3x. Now you're not going to just write 2. It's a positive 2, so you're going to go plus 2. and it's factored. You don't believe me? Let's check. 4 times 4, that's 12, x squared plus 8x. 4, I'm going to minus 1, minus 3x, minus 2. That combines to give me 5x, so I am indeed left with my original right here, 12x squared plus 5x minus 2. Right. 12x squared plus 5x minus 2. It worked. So you don't need to do this every time. I just did that to show you that, yes, it does indeed work. It gives us our factors. But again, that's not how I do it. But if you do it that way, that's perfectly legit, perfectly fine. I don't care which way you factor as long as you factor a way. Don't just write down the answer and say, oh, I factored magically. Unless A is 1, then you might be able to get away with that. But typically, no. Here's a way they actually taught me. I don't like it. I don't use it. I actually do it in my head, but I know my math facts. If you don't know your math facts, this is going to be tough. Grouping. So we've got to, again, figure out what A times C's factors are that combine to give us a 5. Well, we already know it. So I'm going to rewrite this equation. I'm going to write it as 12x squared. But instead of plus 5x, I'm going to write that as plus 8x minus 3x. Now, I did that because I remembered from the last time that if you didn't notice, this is the same problem. I'm going to do the same problem 3 times, just so you can see the different ways. At the end, your choice of which way you do it. But we knew 8 times 3 is 24. In fact, that's A times C. And if we combine them, we get a 5. So that's how we do it. Now we need to group. What's our grouping symbol? Parentheses. So I'm going to group the first 2. I'm going to group the second 2. Okay, we got to be careful here, though. See how that's a negative? Can't happen. That's got to be a plus. No choice. That must be a plus sign right there. If it's not, you make it 1. How do you do that? You put plus negative 3. Minus 3 plus negative 3, same thing. Then you group it. Okay. So now we factor out the GCF. Sounds familiar, right? Exact same thing as the area model, just written differently. In fact, we're factoring the dang quadratic. We're doing the same thing. It's just different visuals. So whichever visual works for you, go with it. 12 and 8 got a 4 up in them. X squared and X got an X up in them. I'm left with, I'm going to do it in a different color. 3x plus 2. These ain't got nothing, but they got a negative, right? Negative 1. Just like last time. So that's a positive 3x now and a positive 2. Okay, so here, how many terms do we have? 2 terms. We're going to factor out the GCF between those 2 terms. What are our 2 terms? This term, because it's no plus sign here, is multiplied. And this term. What do those 2 terms have in common? I'll give you a hint. I wrote in a different color for a reason. They both have 3x plus 2 in them, right? So I'm going to factor that out. 3x plus 2. If I take that out of this term right here, I divide it by 3x plus 2. They cancel. I'm left with 4x. Easy, right? It's just what it is. Now, if I look at this term right here, if I factor out the 3x plus 2, I'm left with a negative 1. Go. It's factored. Same thing I got right here. but it's in a different order. What's 2 times 3? 6. What's 3 times 2? 6. Order doesn't matter, multiplication is commutative. So yeah, that's perfectly fine to write it either way. Okay, so that's the grouping method. That method is actually very useful whenever we're factoring cubics and higher degree polynomials. Not so much for quadratics. There's probably a dozen other methods, but those are the two most common ones. And then there's the way I do it. So it's, again, the process, the thinking is the same every single time. But I use what I call the AC shortcut. I don't know, it's not in a book or anything. But it's a shortcut, really is what it is. For solving, though, we're actually going to get the solution before we get the factors. But it works for factoring. Just have to think about it. So here's what we do. We make a t-table, a chart, whatever. Or you can think about it in your head. But we do a times c. What's a times c? 12 times negative 2, negative 24. And we want the factors that add up to b. It's b, 5. Seems familiar? Yeah, same thing. So I guess you could also do this chart for the other two methods. And then I'm just going to write down my factors. It's a negative, so one's got to be positive, one's got to be negative. This is positive, the little guy's got to be negative. So I'm just going to go in order. I know 1 times 24. If I combine those, does that give me 5? No, it gives me 23. And negative 2 and 12. That gives me a 10. That ain't it. Negative 3 and 8. Oh, bing, bing, bing. That's a 5 winner. Yay. So now I'm going to write down the answer, the solution to this thing. We haven't learned how to do that yet, but I'm about to show you. So this shortcut is, again, getting your zeros first, your solutions. But we can work backwards with that. So one thing I didn't mention, 12 and 5, they don't have a GCF, right? GCF is 1. So we don't have to worry about the GCF, but that's the first step to check for is a GCF. But this one didn't have it, so we didn't have to worry about it. Yeah, not off the topic. So here's my factors, the negative 3 and the 8. Same negative 3 and 8 we've been dealing with. What you do is you put your factors over A, but you got to change the sign, so negative factors. So again, I don't have any like things to do. I made a proof that this actually worked. I named this C and E, but little C and little E, or E and F or something, I don't know. But these two guys, your factors, change the sign, stick them over A. That's what X equals. So X equals negative 3 over A is 12. X equals, so it's your solution, not your factors, negative 8 over 12. Simplify those. 1/4. Use a calculator. And that's going to be negative. They both have a 4 in them, so that's 2/3. Okay, so that's the solution. So this is, we're learning how to factor to get the solutions if you didn't know. But we already got the solutions from this method, so we could skip the whole factoring step. Sometimes, though, sometimes you do need a factor. So I'm going to show you how to take your answers, your solutions, and get your factors. Some of you are thinking, oh, wait, I know how to get my answers already without doing any work at all. So if I get a 4th and negative 2/3, I can just write down those and get my factors. I need to see some work. Come on, guys. You can do that later. For this topic, you gotta show me the way. You know the calculator can do it, and you know the calculator can do it. I know you know the calculator can do it. I need to see the work. So you gotta solve for zero. What? Solve for zero? Make this thing equal zero. Get everything to one side. But no fractions. Okay. Fractions. No one likes fractions. So here we go. I'm gonna get rid of my fractions first. How do I get rid of my fractions? Multiply by my LCD. Multiply both sides, get by 4. 4x equals 1. Is that too much for you? Times 4, times 4, 4's cancel, 4x equals 1. I needed it to equal 0, so I'm bring that 1 to the other side. 4x minus 1. Does that look familiar to you? Okay, over here, same thing. 3x equals negative 2. So 3x plus 2. That's my factors. Done. Same thing I've been getting. Every single method I've done it. So that actually is an entirely extremely useful skill, is taking your zeros, your roots, your solutions, and turning them into your factors. You will need to do that in college algebra or algebra 3 or whatever you're taking next year. So know how to turn a root into a factor, because this works for any polynomial, any equation. If you know what your root is, set it, solve for 0, and that gets you your factor. So you can have like 5 or 6 of them. And then you can answer the equation that says, find the polynomial who has zeros 1, 2, 3. And then you can just say x minus 1, that's x minus 2. Yeah. Anyway, that's next year. Talk about it. So sometimes the quadratics are nice, and the a is 1. If a is 1, it's not a times c, it's just c, right? So you can think of, what are my factors of 45 that add to give me 14? 9 and 5. So for these, if you are fluent with your math facts, if you know your multiplication tables, you can kind of do these without any work. AC method still works, but you don't have to. I'm gonna do the AC method in a minute. First, I'm gonna show you it's x squared, right? I have no options there. It's gotta be x times x. That's the only way I can get x squared. 45, well, I need that to add up. This tells me I have to add. If it's minus, it has to subtract. 45 to up, sorry, it has to be the same sign. It has to add 14. 9 and 5. 9 plus 5 is 40, or 9 times 5 is 45. 9 plus 5 is 14. Positive, so they're both positive. I factored it. That's how I factored way back in the day. I just look at my A and my C and figure out what went where. It's called guessing and checking method. I wouldn't suggest it unless you're extremely familiar with your math facts. Anyway, let me redo this, showing you that the AC method still works. 45 and 14. Well, you could do 1 and 45. That's not going to work. That's 46. 2 doesn't work. 3 and 3 times what? 1 and 5, 15. No, that's 18. 5 and 9. There we go. So negative 5 over, what's my a again? I forgot. 1. That's the first thing x equals. So my factors are going to be, that's over 1, right? So it's anything divided by 1 is itself. X equals negative 5, so x plus 5. And x plus 9 for my factors. AC shortcut still works. Either way you do it. Now this is a negative. That means my factors have to be opposite signs, because to get a negative, I need positive times negative. I can't do negative times negative, that gives me a positive still. So I can do this in my head really fast. If you can, great. If you can't, use AC method. I know I need 9 and 8 because they're 1 apart. Now it's negative, so one's positive, one's negative. The bigger one has to be this sign, negative. Factored. Again, that's not too terrible if a is 1. Don't try and do that if a is not 1, though. If a is not 1, AC shortcut, or area model, or grouping, or whatever the heck you want to do. But don't try and guess and check. So first thing I'm going to check for is my GCF. Do I have a GCF in here? I got a 250. No GCF. So GCF, greatest common factor, would have to be in everybody. There's nothing that goes into 2 and 15, so done. Almost done, guys. It's a long video, I think, but it's going to cover like 2 or 3 one day. Factor out the GCF, done. A times C, 2 times 18 is 36. And I need that to add up to a negative 15. Wait a minute, that's a positive 36. So they have to be both positive, right? They have to both be the same sign. That's negative, and they both better be negative. So negative 1 and negative 36 obviously doesn't work. You don't have to start at the beginning. If you know it doesn't work, just keep going. How about 3? Negative 3 and negative 12. There we go. I skipped negative 2 because I knew it didn't work. If you don't know your math facts, then don't skip. Go in order. That's negative 15. That's my factors I need. Negative 3 over 2. Negative, and that's x equals. Let me write that down. Negative 12 over 2. That's to be positive. Simplify it first. So x equals 3 halves. X equals 6. No freaking fractions. 2x is 3. 2x minus 3 for one of my factors. And x minus 6 for my other. All I'm doing is solving these things for 0. So there it is, factored. Okay, next. 5 and 22, nope. No GCF here. It could also be something random, like they could all have a cat in them. Or you know, like X. It might be X's, like everybody's got an X and you just factor that out. Whatever. Could be some other variable than what you're dealing with. Doesn't have to be a number. Any GCF, take it out first. That's kind of big, huh? 5 times 48, well, that's going to be what? 250 minus 10 is 240. Let me double check. 48 times 5, I know it's negative. 240. And you set up to 22. If you think 1 and 240 is going to work, something's wrong with you. but that's negative 240 because that's a negative and that's a positive. I'm gonna go with 10 because, you know, that'll tell which way to go. 10 and 24 because, well, that's 24 times 10. I see that. You don't see it just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down. You find what works. Yes. This isn't divisible by 7, I don't believe, but you just say calculator. What's 240 divided by 7? It's not. Calculator. That's 240 divided by 6. 40. So you do 6 and 40. That doesn't subtract to give you 22. Okay. So I wrote those two close together. It needs to be a positive 22, so it has to be negative, so that gives me 14. So it's something before negative 10. Or before 10. So let me go down. I'm not going to try 9. I'm going to try 8. 30. 8, 30. Oh, there we go. Calculator. What's 240 divided by 8? 30. And if I do negative 8 plus 30, that's 22. So there's my A and my C. This might help some of you. Might confuse some of you too, though. I'm going to show you. Your calculator can give you what's called the prime factorization. It can tell you what are all your possible factors, basically. So if you take 240 and I guess just hit enter, shift, factor, it'll give you this. So that means you got 4 2's to work with, a 3 and a 5. So you could do 2 times, well, 2 times 2 times 2 is 8, times 3 is 4, times 5 is, I forgot, or was I? 120, yeah. So you could do 2 times 120, or you could do 15 times 16, because 2 to 4 is 16, 3 times 5 is 15. Or you could do like 2 times 2 is 4, so that's 12, and another 4 times 5 is 20. So you can, as long as you use those factors, you can multiply them in any order you want to, and those, that will give you all your different possible factors. Or you can just go down the list. Whatever's easier for you. So this is the hard part right here, figuring out what your numbers are. Negative 8 over 5, negative 30 over 5, so x equals 8/5, x equals negative 6, 5x minus 8, x plus 6. So again, you're just getting rid of your fractions, so that's going to be 5x equals 8. Then it's a positive 8, so I'm going to subtract it. And we equal 0. Everything good. Okay. So right here, I'm going to do A times C. I'm going to do 8 times 96, and I'm going to get 768. And then if I did all that work, I get some big numbers, and I get a huge mess, and it wouldn't be factored correctly. Why not? Tell me that it has a GCF. If you did, you're right. So there's a GCF in here. They're all even, so I know it's at least 2. I don't know what it is off the top of my head, but calculator does. So take the 2 biggest ones and find their GCF first. You can't do 3 at a time. 2 at a time, 2 at a time. So do 56 and 96. See what they have in common. Then we're going to take this answer we get and do it with 8. Okay, so obviously it's 8, right? The GCF of 8 and 8 is 8. So our GCF is 8. Factor it out first. Your GCF first. You don't, you'll just be wrong. If you do the AC shortcut without factoring out your GCF first, you'll get a factor. It'll be correct, except you'll have your answer without the GCF out. So it'll be wrong. It'll be the right zeros, but your GCF is just a multiple of those zeros. So it's the AC shortcut simplifies, it cancels those out. You won't know what it is. So just make sure, let me some big old brackets, that you factor out your GCF first, and you'll be good to go. So now it's super duper easy. You can use the AC method if you want. But it's got a 1 here, that's a 12. It needs to add up to 7, 3, and 4. And you can drop off the brackets. For me, you won't have to. Later on, you will have to. Might as well do it now. You want to go through the AC shortcut on that. It's factors of 12 that add up to 7. Well, 3 and 4 obviously are it. Negative 3 over, what's my A? 1. You go with this A. X equals negative 4 over 1. So that's going to be x plus 3. Oops, x. Our variable's y, right? So I'm wrong variable, my b. And x plus 4. There you go. Done. It's the same thing either way. But you know, this just gives us this part. Don't forget your GCF is still on the outside. It's times whatever you get here. Now, okay, this is a P and I put X's. Sorry. This is an X and I put X's. Okay. X's. We're pretty much gonna be dealing with X's mostly, so it's okay. Just try and match a variable. It's the same thing. There should be no work involved on these. These are a difference of squares. If you see this, you should be able to factor it immediately without thinking. Problem is, you probably don't know what square is, huh? So x squared is x squared. So that's 1 square. 4 is 2 squared. So this is a difference of 2 squares. It factors as the roots, square roots, x and 2 with opposite signs, plus and minus. X plus 2 times x minus 2 is x minus 4, x squared minus 4. Same thing here, y minus 9, y plus 9. These require no work, and it'll save you a lot of time. You can actually just look at them and see that, oh yeah, that's a difference of squares. So these are easy to see. You might have something like this, which is not so easy to see. Ew, yeah. What do I do first? C, F. I got some 2s, I got some A's, and I got some B's. How many A's? I got 2 A's. How many B's? I got 1 B. Oh, that's going to leave me with 1 minus 16 A squared. Difference of squares. 1 is 1 squared. 16 is 4 squared. A squared is A squared. That's going to be, don't forget this guy. Closer. 1 and 4a, the square root of that, square root of that, square root of all your pieces you have, 1 and 4a. One of them is a plus, one of them is a minus. Doesn't matter which is which, obviously, because multiplication is commutative. That's it. We're done. Continue later. Goodbye.